Notes on types of polynomials. A polynomial function is a function that consists of variable terms with positive integers as exponents, whole numbers. The terms can be combined with addition, subtraction, multiplication, and division. Once the terms are combined, they form the polynomial. There are many different types of polynomials. We have already studied two different types of polynomials, linear and quadratic functions. Each polynomial has its own unique shaped graph that clearly identifies it from the other types of polynomials. Since there are so many different types of polynomials, they are identified by the largest exponent in the function and the number of terms. This is similar to having a first and last name. So here are all of the possible first and last names polynomial functions can have. The degree, which is the first name, is the largest exponent. If the largest exponent in the polynomial is 0, we call this a constant function. That happens when we have something like just a number. If the largest exponent in the polynomial is 1, we call that a linear function. And that looks something like 5x, because 5x has an invisible exponent of 1. If the largest exponent is 2, we call that a quadratic function. If the largest exponent is 3, we call that a cubic function. If the largest exponent is 4, we call that a quartic function. If the largest exponent is 5, we call it a quintic function. After that, we don't have fancy names. We just call it by its number for 6 or higher. You would just substitute the number in, so 6th degree, 7th degree. The number of terms is the possible last names. So if there is one term in the polynomial, we call that a monomial. If there are 2 terms, we call it a binomial. If there are 3 terms, we call it a trinomial. And if there are 4 more terms, then we call it a polynomial, because the word poly means many. Polynomials are written in standard form and then classified by their degree and by the number of terms in the function. Okay, standard form of a linear function that we know is generally f of x equals mx plus b, or slope-intercept form. Standard form of a quadratic function we know from Unit 2 is ax squared plus bx plus c. Standard form of a cubic function, you'll start to notice a pattern, is ax cubed plus bx squared plus cx plus d. Of a quartic function is f of x equals ax to the 4th plus bx cubed plus cx squared plus dx plus e. And then quintic function, f of x is equal to ax to the 5th power plus bx to the 4th power plus cx cubed plus dx squared plus ex plus f. Now you can have any combination of any of these terms, a, b, c's, and so on and so forth. The only thing that is required that if it is quadratic, it has to have an ax squared term. If it's cubic, it has to have an ax cubed term. If it's quartic, it has to have ax to the 4th, and if it's quintic, it has to have ax to the 5th. Otherwise, it wouldn't be that type of function. So now we're going to do some examples where we're going to write the polynomials in standard form and then classify them by their degree and the number of terms. So standard form, we have to start with the largest exponent. So in number 1, that is 5x cubed. After that, we have 3x squared. Next is the linear term 2x, and finally the constant term minus 4. So now that this is written in standard form, we can go ahead and classify it by its degree. So the largest exponent is 3, so we call that a cubic function. And because there are 1, 2, 3, 4 separate terms, we call that a polynomial. Okay, in example 2, I'm looking at the entire expression. I see that the largest exponent is the largest exponent is 4, so 2x to the 4th is my first term. After that, I'm looking for a cubic term. We don't have one. So now I move on to the next one, which would be power of 2. So we have negative 3x squared. Then I have 5x, because that comes next. And then I have some like terms, negative 1 and 6. Add those together and you get 5. So now the largest exponent in this expression is 4, so that's called a quartic function. And once again, there is 1, 2, 3, 4 separate terms, so this is a polynomial as well. In example 3, the largest exponent is power 5, so we're going to start with negative 2x to the 5th. After that, I'm looking for the 4th power, but I don't have one, so I move on. Plus 5x cubed And then I have some like terms. 1x squared and 2x squareds combined to be 3x squareds. So now the largest exponent in the expression is 5, so we call that quintic. And there are 1, 2, 3 separate terms, so we call that a trinomial. Okay, looks like we have quite a few pairs of like terms in example 4. So we have the largest exponent is the power of 4. So we're going to start with 3x to the 4th. Next I see I have a few powers of 3. Negative 2x cubed and positive 2x cubed cancel each other out. And so now I have just 4x cubed. And then negative 5 and positive 5 also cancel each other out. So it looks like this polynomial combines to be 3x to the 4th plus 4x cubed. The largest exponent is 4, so we call that quartic. And there are 1, 2 terms, so that is a binomial. Quartic binomial. Okay, in number 5, we have 5x squared and negative 5x squared, so that cancels out. Then we have negative 3x and positive 3x, so that cancels out. And then we have 4 and 4, that adds to 8. So this is called, because it's just a number, we call it a constant. And because there's only one term, a monomial. A constant monomial. Okay, now that we know about the different types of polynomials, we're going to move on to the different shapes of polynomials. Okay, so we'll go ahead and do number 1 together, and then you can continue on with 2 through 5. For the following functions, determine the classification of the function and then use your graphing calculator to create a sketch of the graph. Then determine the number of turning points. Okay, so once we graph it, we'll see how many times the graph turns. Okay, number 1, the polynomial is p of x equals negative 2x plus 1. Okay, so I'm looking at my variable term, and I see that there is no exponent here, so that means an invisible exponent of 1. Not 0. Since there is a variable, it can't be 0. So the degree is 1. We call that a linear function. And there are 1, 2 terms, so we call that a binomial. Nope, that's not what I wanted to write right there. There are 2 terms. Okay, so we're going to go ahead and graph this on our calculator. I know this is going to have a y-intercept of 1, and it's going to go down to an over 1. Because this is a linear function, it's going to be a straight line, so your graphing calculator should give you a graph something like this. So now as you read the graph from left to right, you want to see how many times it turns. And this function doesn't turn at all, so it has 0 turning points. And the shape of the graph is a straight line. Okay, so you're going to go ahead and go on to number 2. Telling me that the degree is the largest exponent 2 and that there are 3 terms, and then going ahead and classifying that. Once you finish with this page, there is a conclusion page for you to work on.